Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So let's get going. Problem. Solve y double dash plus 2y dash plus 5y equal to e power minus x secant 2x or d square plus 2d plus 5 into y equal to e power minus x secant 2x using variation of parameters method. So we are given a differential equation of order 2. Y double dash plus 2y dash plus 5y equal to e power minus x secant 2x. Consider as equation number 1. Now we can write the given equation as d square y by dx square plus 2 into dy by dx plus 5y equal to e power minus x secant 2x, right? D square y by dx square can be written as capital D square y using the differential operator d plus 2 into write dy by dx as capital dy plus 5y equal to e power minus x secant 2x. Now take y common from all the three terms of LHS. We'll get d square plus 2d plus 5 into y equal to e power minus x secant 2x. Consider it as equation number 2. Now see, equation 1 in operator form is equation 2, right? So f of d into y equal to some function of x, where f of d is d square plus 2d plus 5 and r of x is e power minus x secant 2x, right? Now we'll find the solution to our problem using the general solution is given by y equal to yc plus yp, where yc is complementary function, yp is particular integral. We'll find yc using the auxiliary equation and later using the auxiliary equation, yc, we'll find yp. Okay, now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 2d plus 5. Let's replace the differential operator by m, so that we'll get f of m equal to m square plus 2m plus 5, and the auxiliary equation becomes m square plus 2m plus 5 equal to 0. Just compare this equation with quadratic equations. Am square plus bm plus c equals to 0, we'll get a equal to 1, b equal to 2 and c equals to 5, right? Now we'll use the quadratic formula minus b plus r minus square root of b square minus 4ac by 2a to find roots to our equation. To our auxiliary equation. We'll get minus 2 plus r minus square root of 2 square minus 4 into 1 into 5 by 2a. This gives us minus 2 plus r minus square root of 4 minus 4 5 is 20 by 2, which gives us minus 2 plus r minus square root of minus 16 by 2, right? Now let's write square root of minus 16 as minus 1 into 16 by 2. Now we can write or split the square root as square root of minus 1 into square root of 16 by 2, since square root of minus 1 is I and square root of 16 is 4. Then we'll get minus 2 plus or minus I 4 by 2. Now take 2 common from the numerator. You'll get 2 times minus 1 plus or minus 2i by 2, where 2 gets cancelled, and you'll get m equal to minus 1 plus or minus 2i. A pair of complex conjugate roots. We know that when roots are complex conjugates, say a plus or minus ib, then yc looks like e power ax into c1 cos bx plus c2 sin bx, right? Now coming to our complementary function. Yc equals to, just compare a plus or minus ib with a minus 1 plus or minus 2a, then for a equal to minus 1 and b equal to 2, we'll get yc equals to e power minus 1 into x of c3 cos 2x plus it's c1, right? c1 cos x plus c2 sin 2x, which gives us e power minus x of c1 cos 2x plus c2 sin 2x. Therefore, yc equals to e power minus x of c1 cos 2x plus c2 sin 2x, or yc equals to c1 e power minus x cos 2x plus c2 e power minus x sin 2x, right? Let yp equal to, just replace the parameters or constants with some functions of x, a and b. We'll get yp equal to a e power minus x cos 2x plus b e power minus x sin 2x, where a and b are functions of x. Right? We can compare yc with c1u plus c2v or yp with au plus bv to find u and v. Okay? If we compare these two, you'll get u equal to e power minus x cos 2x and v equal to e power minus x sin 2x, or if you compare these two, you'll get u equal to e power minus x cos 2x and v equal to e power minus x sin 2x. We'll get the same thing. U equal to e power minus x cos 2x and v equal to e power minus x sin 2x. Okay, here a is given by integral minus v into r of x by u v1 minus v1 into dx, and b is given by integral u into r of x by u v1 minus v1 into dx. If you observe, we are having u v1 minus v1 in both the formulae. So we'll begin with u v1 minus v1 and later we'll find a, b, yp, and finally we'll put yc and yp in the general solution formula. U into v1 is nothing but derivative of v with respect to x, minus v into u1 is nothing but derivative of u with respect to x. Here u is e power minus x cos 2x into v is e power minus x sin 2x minus e power minus x sin 2x into derivative of e power minus x cos 2x is equals to e power minus x cos 2x into derivative of, or uv whole dash equals to u dash v plus v dash u, right? We'll apply this formula. We'll get e power minus x whole dash sin 2x plus e power minus x into sin 2x whole dash minus e power minus x sin 2x into e power minus x whole dash cos 2x plus e power minus x into cos 2x whole dash. This gives us e power minus x cos 2x into derivative of e power minus x with respect to x is minus e power minus x into sin 2x plus e power minus x into derivative of sin 2x with respect to x is 2 cos 2x minus e power minus x sin 2x into derivative of e power minus x with respect to x is minus e power minus x cos 2x plus e power minus x into derivative of cos 2x with respect to x is minus 2 sin 2x, right? This gives us e power minus x cos 2x into minus e power minus x sin 2x plus 2 e power minus x cos 2x minus e power minus x sin 2x into minus e power minus x cos 2x minus 2 e power minus x sin 2x, right? Which gives us minus e power minus x sin 2x cos 2x plus 2 e power minus x cos 2x into cos 2x is cos square 2x, minus into minus plus e power minus x sin 2x cos 2x, minus into minus plus 2 e power minus x sin 2x into sin 2x is sin square 2x. So here minus e power minus x sin 2x cos 2x plus e power minus x sin 2x cos 2x gets cancelled, and you can take 2 e power minus 2x, or just replace e power minus x into e power minus x. We can write e power minus x into e power minus x as e power minus x which is e power minus 2x, right? Just replace e power minus x into e power minus x with e power minus 2x. Okay, here and here we are going to replace e power minus x and e power minus x with e power minus 2x, and we'll get 2 e power minus 2x cos square 2x plus 2 e power minus 2x sin square 2x. Now just take 2 e power minus 2x common from these two terms. We'll get 2 e power minus 2x of cos square 2x plus sin square 2x. This gives us, or you can write this as sin square 2x plus cos square 2x. Since sin square theta plus cos square theta equal to 1, so we'll get 2 e power minus 2x into 1, which is equals to 2 e power minus 2x. Therefore, uv1 minus v1 equal to 2 e power minus 2x. Now coming to A is given by integral minus v into r of x by uv1 minus v1 into dx. This is equals to integral minus v is e power minus x sin 2x into r of x is e power minus x secant 2x by uv1 minus v1 is 2 e power minus 2x into dx. This is equals to integral minus e power minus x sin 2x into secant 2x by 2 e power minus 2x into dx. We know that e power minus x into e power minus x is e power minus 2x. This gives us e power minus 2x sin 2x secant 2x by 2 e power minus 2x into dx. Here e power minus 2x gets cancelled. We'll get minus 1 by 2 integral sin 2x into secant 2x dx. Since we know that secant theta is reciprocal of cos theta, so we can just replace secant 2x with reciprocal of cos 2x. So we'll get minus 1 by 2 integral sin 2x into reciprocal of cos 2x dx, which is equals to minus 1 by 2 integral sin 2x into 1 by cos 2x is sin 2x by cos 2x, which is tan 2x, right? This gives us minus 1 by 2 integral tan 2x dx. Since integral tan a theta d theta equal to minus 1 by a log mod cos a theta or 1 by a log mod secant a theta. Here we are having already minus 1 by 2, right? So I'll pick the first one, minus 1 by a log mod cos a theta. This gives us minus 1 by 2 integral tan 2x dx. For a equal to 2, you'll have minus 1 by 2 log mod cos 2x, right? Or 1 by 4 log of cos 2x. Therefore, a equal to 1 by 4 log of cos 2x. b is given by integral u into r of x by u v1 minus v1 into dx is equals to u e power minus x cos 2x into r of x e power minus x secant 2x by u v1 minus v1 is 2 e power minus 2x into dx, right, is equals to integral e power minus x into e power minus x cos 2x secant 2x by 2 e power minus 2x into dx. We know that e power minus x into e power minus x is e power minus 2x, so this gives us e power minus 2x cos 2x into secant 2x by 2 into e power minus 2x dx. Here e power minus 2x gets cancelled and we'll get 1 by 2 integral cos 2x secant 2x into dx. Since we know that secant theta is reciprocal of cos theta, so we'll replace secant 2x with reciprocal of cos 2x. We'll get 1 by 2 integral cos 2x into 1 by cos 2x into dx, where cos 2x gets cancelled, we'll get 1 by 2 integral dx, which is 1 by 2 x or x by 2. Therefore, b equal to x by 2. Now coming to yp. Yp is given by a e power minus x cos 2x plus b e power minus x sin 2x. Right? Now substitute a and b, where a is 1 by 4 log of cos 2x into e power minus x cos 2x plus b x by 2 into e power minus x sin 2x, right, which gives us 1 by 4 e power minus x cos 2x into log of cos 2x plus 1 by 2 x e power minus x sin 2x, which is our required yp. We got yp and yc. Let's now write the general solution using y equals to yc plus yp. Therefore, the general solution is given by y equal to yc plus yp. Then y equal to yc is e power minus x of c1 cos 2x plus c2 sin 2x. Yp plus yp is 1 by 4 e power minus x cos 2x into log of cos 2x plus 1 by 2 x e power minus x sin 2x. This completes the problem. So this is all for now. I hope you'll understand. We'll see you in the next video. Until then, bye bye.